All right, we're live. Welcome everyone to another stream. I think today is going to be an interesting one. Chat, let me know how everything sounds, if there's any issues with audio or anything like that, and if not, we're going to get started. I guess today what we're going to be talking about is WebAssembly. And specifically talk about WebAssembly not running in the browser, so WebAssembly running somewhere else. If anybody in chat has any questions or anything like that, feel free to put those in the chat, and I'll be happy to answer them. And without further ado, we'll get started. So I want to start basically by talking about what WebAssembly is and what it's used for, and why I'm particularly excited about it. So basically, WebAssembly is a binary format that can be run usually, and the way that it started is that it was run inside of the browser. And basically, what WebAssembly is it is a virtual machine in the kind of original sense of the term. And by that, I mean WebAssembly is a conceptual machine, a machine that doesn't actually really exist. It theoretically exists, and it has an instruction set that basically can be executed, but this machine isn't a physical machine. And so basically what you do is you write code for this conceptual machine, and then it gets compiled by some compiler into instructions that run on an actual host machine. So I'm running here on a Mac. It's an Intel chip. And so when I write WebAssembly, I can then compile that WebAssembly that's for this conceptual WebAssembly machine, and compile it into the Intel x86 instructions that will actually be run on my real machine. And then relatively recently, this blog post that you can see here on my screen was posted by Lynn Clark on the 27th of March, 2019. What it is all about is this idea of WASI. And what WASI is a specification that allows WebAssembly binaries to talk to a host machine in some way, usually to the host machine's operating system, through a well-defined API. WASI in particular is kind of POSIX. I don't know if it's meant to be 100% POSIX compliant. I think they mentioned that here in the blog post, but it is definitely POSIX-like. And so if you're coming from the Linux kind of background, then you'll be familiar with that. So basically this thing is setting up the system calls that allow you to do things like open up, like write to files, open files, create files, delete files, open up TCP sockets, get random numbers, all the things that the operating system kind of usually provides to an application. As you can see, again, this is from the 27th of March, so it's relatively new. And the specification is by no means complete at all, so we will be kind of diving a bit deeper into this later on. There's a lot of things that it doesn't yet allow you to do, but the promise of this is that eventually you'll basically be able to do anything inside of a WebAssembly program that you would be able to do, running a program natively on top of an operating system. So we have WebAssembly, we have WASI, which allows it to talk to a host machine, but we need compilers that will compile the WebAssembly to actual code, and we need a runtime that basically exposes this WASI interface to the program. And when the program calls it, it will actually it knows about the real host machine that it's running on, and it will do the right thing. So if it's running on Linux, it will go ahead and, when the WebAssembly binary calls into, create a file or whatever, it will then go ahead and call the Linux kernel and actually create a file and return back a file descriptor to that file. And if it's running on Windows, it will do a similar thing using Windows system calls. But the WebAssembly program has no idea which operating system it's actually running on. It will do the same exact thing for, if it's running on Linux or if it's running on Windows, it has no idea. And in fact, it has so little idea that, it doesn't even have to really be running on an operating system. It can make those calls inside of a web browser. And so there's already a polyfill for these things inside of a web browser, and the web browser will kind of do whatever it can to implement that interface. So this thing can kind of run anywhere. So again, we need a compiler, we need this interface. There's 2 implementations so far. Two implementations that are really starting to pick up steam in this. One is something called Lucette. I think it's pronounced Lucette. And basically, it's from this company called Fastly. That the reason that they've created this is basically to be able to run serverless applications. And so, again, Lucette basically compiles the WebAssembly program to native code, like actual native assembly, and then provides a WASI compliant interface on top of it, so that when you actually run the code, it will be able to talk to the host system. And Lucette does this in 2 steps. It first compiles the code, and then you take the compiled code and you feed it into a runtime. But there's a second toolchain called WASI-land that does this all in kind of one go, or at least when you kind of run the command, it will compile the thing and then run it for you. WASI-land is underneath this Crane Station organization on GitHub, which is kind of being basically funded by Mozilla. And Crane Station also has the JIT compiler CraneLift, which is actually the thing responsible for compiling WebAssembly. It eventually will be the thing that runs WebAssembly inside of Firefox. It's not quite ready. I think it's in nightly Firefox, but it's not in production Firefox yet, but eventually it will be. All right, so chat is asking if I can kind of recap what I just talked about for people just joining. So we're talking about WebAssembly. WebAssembly is a theoretical machine, doesn't really exist. You can write code for that machine, and then using this WASI-time or Lucette, compile the code for that theoretical machine into actual real assembly code that will run on your machine. And then Lucette and WASI-time both offer up a runtime that allows your WebAssembly compiled program to talk to the host machine through a well-defined interface called WASI, which is what we were talking about here. And so WASI is really just a specification for how a WebAssembly program can talk to a host machine that it's running on top of. And it's very recently been announced, and so kind of new on the scene. And so basically, like, why does this matter is the question we're going to move on to now. Like, why, like, this is all well and good. You might be thinking of other technologies that have similar-ish promises to them. You might be thinking about virtual machines like the JVM or the CLR for .NET, or you might be thinking about other environments that provide like a way to kind of run things on like in a sandboxed way, like Docker or something like that. And we'll kind of address all these in turn. So there's two kind of big advantages of this technology. One of them is sandboxing. So when you're running a WebAssembly program, again, it doesn't know what host it's running on. It actually knows nothing about that host. And so it's very hard for the program that's running there to do anything malicious. And in fact, if we didn't expose that program to the host machine through this WASI interface, you would be able to kind of, the program wouldn't really be able to do anything at all. It would simply just be able to kind of spin your CPU, and cause it to go into an infinite loop or something like that. But, other than that, it wouldn't really be able to do anything bad because it has no exposure to the internet, no exposure to your file system, no exposure to anything, right? So by default, it's completely sandboxed, and then WASI exposes to the program, a way to, to talk to the host environment. But the nice thing about these implementations is that you can have fine-grained permissions on top of this. So let's say you don't want the program to be able to have access to your whole file system. You just want it to be able to talk to or have access to this one particular directory and all the subdirectories underneath that directory. That's possible. Or you want it to be able to open up TCP connections, but only on port, 475 or something like that. I don't know. You'll be able to do that. So I think an interesting way to think about it is like in the Node world, in Node.js world, you have V8, which is the engine that runs JavaScript inside of Node and of course also inside of Chrome. And when you're thinking about V8, it's a completely sandboxed environment. It has no way of talking with the outside world. So it can go ahead and execute JavaScript all at once, but there's no way for it to really do anything other than just, execute that JavaScript and can't talk to your file system, it can't talk to the internet, can't really do anything. And what Node did is take that JavaScript execution environment and kind of poke holes in it to give it a way to talk to the outside world. The unfortunate thing, and if you listen to Ryan Dahl, who is the creator of Node, talk about this and why he's kind of created a new project, Deno, to address these pitfalls, is that Node kind of opens it up and doesn't lock it down in any way. So it gives you full access to the to the file system. It gives you full access to the network with no way of kind of controlling that. But this WebAssembly environment through WASI does give you that way. Okay, so we have a sandbox environment where we can give fine-grained control to things, but you might be thinking, okay, well, there are some other sandboxes out there that do a good job of this. To a certain extent, some things like the JVM are sandboxed in this way, although again, you don't get quite as good fine-grained control. And Deno, the new thing from Ryan Dahl, is a way to address this. So what else? Like, what makes this different again? And the fact is, this environment is much more lightweight. So it's meant to be a very, very thin kind of layer around the program that's running, and not provide a super huge runtime on top of it. So basically, all the overhead of the program running are the resources that the program takes and things like that are basically just whatever the program itself is actually using. There's not a ton of resources being taken up by the WebAssembly runtime itself. And so you can kind of contrast this with, for example, Docker. Docker is a good example here, where you also have this really, really fine-grained sandboxing, but you're running an entire user land on top of this thing. So the only thing that's kind of being shared at runtime is the kernel. But all the other stuff that's running on top is, you have an entire user land that might come with a whole bunch of things. And if you just want to run a program, it's not only the program that's running, but it's the entire user land that kind of has to come along with it. And so WebAssembly kind of strips that away and says the only thing that we have to worry about is running the program itself and having a thin shim around that program. And of course, WebAssembly, unlike a lot of these other technologies, like Node, for instance, is completely language agnostic. So as long as your language can compile down to WebAssembly in some form, then there should be no problem. And there's already big efforts going on for, obviously, Rust is a huge language that can compile to C++ can compile to WebAssembly. Go can already compile to WebAssembly. C# can compile to WebAssembly. And then there's also work going into getting dynamic languages running on top of WebAssembly. So like compiling the Python, like CPython, runtime to WebAssembly, and then being able to run Python projects inside of that WebAssembly sandbox. And so it's still early days, but there's a lot of work going in there. So I think it's the reason that I'm excited about it in general is because you'll be able to get a lot of like the usage that you would use Docker for today, which Docker is great, and this doesn't replace Docker in total, but it does maybe replace a few use cases of Docker. Like if you just are using Docker to run a program, one program, and that's it, then you can think about using WebAssembly instead, because like if you're going to send that program over the wire, instead of having to send an entire kind of Docker package specification with all of the dependencies, which can be quite large, and of course it caches it locally, so you don't have to worry too much about it. But really, this is the minimal thing here. You're only going to be really sending the program itself, and that's it. The thing that actually has to be executed. And so you can imagine having things like, an app store or something like that, where your apps are packaged as WebAssembly files with, maybe with some bundles around it for assets and stuff like that. And that's all that gets sent down to the environment. And then you can kind of run that program, on the device. And I think what would be interesting about this is maybe, if you have a platform where you want to run apps, instead of having to build sandboxes around particular languages, like for iOS, for instance, having to build a sandbox around the Objective-C runtime, you can just have a sandbox kind of already specified with WebAssembly, expose out to it certain APIs and stuff like that for actually talking to the system in some way. And you don't kind of need to build a custom sandbox for a particular language. You get it all for any language that can run on WebAssembly, which in the future quite possibly could be every language, which would be pretty interesting. Okay, I've talked a whole bunch. I'm wondering, chat, if there's any questions from you or anything like that. Then I think we'll kind of, if not, we'll start diving into the plan for today. So using the Hyperfine command line benchmarking tool, I found that compiled Lucette WASI is dramatically faster than WASM time. Okay, so someone in chat is basically saying that they've found that Lucette is faster than WASM time, and kind of makes sense. So what Lucette is doing is you first compile your WebAssembly to native code, and then in a second step, presumably the step that the person in chat was benchmarking, you then run that native code, with the WebAssembly runtime. And what WASM time is doing instead is compiling the code and then running it later on. And all like those two steps are happening kind of in the same go. And so it could be that the overhead that you're seeing between Lucette and WASM time, that they're saying 1 to 2 milliseconds versus 180 to 280 milliseconds, quite possibly could in large part be the compilation step that's happening. And it's already happened ahead of time for Lucette, and not yet happened for WASM time, or it happens in the same step as actually running the program. Maybe that's the explanation there. The actual compilation tool that both things are using is the same. So they're both using crane lift, and I don't, maybe they're using them in different ways, and one might produce better code than the other. I'm not really sure. But yeah, that might be the big difference there. All right, cool. So let's talk a little bit about what we're doing today. So relatively recently, and I think this is from, well, it says February 13th, but the actual, somebody is real quick mentioned WASMer as a third WASM runtime. Yeah, WASMer is also a runtime. It's not quite yet WASI compliant, at least last time I checked. So let's see here. WASMer. Let's see, they have an issue for it open. Yeah, add WASI here. Yeah. Apparently we just merged. So okay, so they have WASI support now too. We should. Sorry to the folks at LazarMer. They now have WASI implementation too. I haven't used it yet, so that will be interesting to check out as well. So cool. This is a pull request here on the Rust compiler that adds a new target to the Rust compiler, WASM32 unknown WASI. And so instead, before, all you could compile Rust to was WASM32 unknown. And what that means is that you could compile your code to WebAssembly, but the code would make zero assumptions about where you were actually running the code. So I had no idea, just knew that you could run it, like it could compile WebAssembly code, but it didn't know where it was going to run, whether it was a browser or not the browser or anything like that. And so in the web world, what was happening is outside of the standard library and stuff like that, a library called WASM bindgen was being built, and this WASM bindgen basically makes the assumption that you're inside of a browser and can then expose out ways to talk to JavaScript and eventually to web APIs and stuff like that through the JSys and WebSys crates and stuff like that. And so outside of the kind of core compiler and the standard library, this thing was tacked on to be able to talk to JavaScript functions and things like that inside of the browser. And it works really great. And if you've seen my stream before, I've kind of worked on some of the stuff that's going into that aspect of WebAssembly. But with this pull request now you can compile Rust and make the assumption that you're going to be on a WASI compliant system, so that when you want to open up a a file using file open inside of Rust, it will assume that it can call WASI system calls and actually open up files and stuff like that. And it's really great. It's really awesome that this support has already been added to this, considering that it was just announced not too long ago. And so the only issue here is that, there's a few issues. One is the WASI interface itself is not very full. So if we look at, let's see if I can find it. I think I have it open off screen. I'm gonna try and find real quick the specification for all the system calls that WASI basically exposes to the world. Let's see, let me search for it real quick. Need to find the documentation for it. I think it actually might be in here. See if I thought did they link it somewhere in here. Anyway, not a big deal. We'll have to find it a little later on when we're actually working with this stuff, but for now it's not a huge deal. So the issue is that a lot of functionality is not actually exposed through WASI yet. So for instance, there's no way in WASI to create a socket. If you need to create a TCP socket, you can't. There's just doesn't exist any actual system call for creating a socket. There are system calls for reading from sockets and writing to sockets. So if you magically have a socket somehow, you can write to it, but you can't actually create a socket and actually accept a socket. And so, if you want to do networking inside of a WebAssembly thing, unfortunately, that's not really practically possible yet. And so there will have to be extensions to the WASI specification to allow for creating TCP sockets. Okay, so that's all nice and good, but I still, I've been wondering about actually doing networking inside of a WASI, compliant binary, and had the idea of trying to get something like this GRPC client and server called Tower GRPC, which is basically a pure Rust implementation of gRPC. And for those unfamiliar, gRPC is just an RPC protocol from Google, and being used in a lot of different places. And I think the kind of canonical implementation is a C core library, and that's what, if you have a Python gRPC library, it basically is just using the C core library. I think there's a Go one that's just pure Go, and there might be another one. I think maybe a Java, pure Java one, and here is a pure Rust one. And so I thought it would be interesting to see if it, what happens if you try and compile and run the example that they have here. They have a few examples here. Let's take a look here. Let me pop this, make this a bit. So I was looking at the client here. And basically what it's doing is it's creating a connection. Then it's using this hello world client greeter. And then it's going to say hello. So it's basically sending this request and response of what is your name? And then you send back a name and you get the response and stuff like that. So that's what this thing does. And so I just decided to go ahead and try and get this to run. And so inside of here, we're inside of this Tower gRPC project. And if you actually do let's see, where did I have it at? Yeah, so I'm running here cargo, and it has to be nightly because this WASI support is only on nightly for now because it's very unstable. Might change in significant ways, so it's not kind of locked down yet. So we're going to build it on nightly. We're going to target this WASM32 unknown WASI, and then we're going to run the binary called hello world client that's specified here. And if you want to see what that looks like in the cargo.toml here, you can see the binary called hello world client is the one that is defined at source hello world client rs here. So if we actually run that, I think I have to go inside of hello world client. That should work. Oops. Cart. Oh, I got to go into examples and run it. Okay, so we'll run it. And the surprising thing is that this thing almost compiles. And if you actually look at all the errors that you get, they're all inside of one crate. Can you paste your build command into chat? Yeah, sure. So if you go ahead and clone down this repo, you can just run this. And remember, you have to have one of the latest nightlies. I think it was a nightly from a few weeks ago or something like that. So you might have to update Rust. And if you if you don't have Rust, then you should go to rustup.rs, and that's where you can install Rust and all the tool chains and stuff like that. If anybody has questions about how to actually get this not compiling like I have, then let me know. But yeah, like I was saying, if you're looking at this, all of the errors are coming from this net2 crate here. And I was like, net2, I've not really heard of that before. What is that? And so what I did is go up to the top level and look at this cargo lock file here. And then this cargo lock file is basically the thing that specifies what the actual dependencies are and real concrete version numbers. And so if we look at net2 and see what it is the dependency of, then we see it's a dependency of MIOW. And I believe that's it. Yeah. And MIO. So it's a direct dependency of MIO and MIOW. MIOW itself is a direct dependency of MIO. And if you don't know what MIO is, it is a Metal.io project. So let's take a look at that. And this is basically the thing, it's a cross-platform abstraction over very low-level networking to actually do asynchronous networking on different platforms, like on Linux and on FreeBSD and on Windows and, I think Fuchsia, Android, iOS. So if you're doing asynchronous networking in Rust, it's going through this. And so this thing that's not compiling is a dependency of a dependency of MIO, which is already super low level, and really dealing with the lowest level of networking. And so we're kind of deep in the guts here, right? But you would think that if we could go ahead and get this crate actually compiling, And in a way, if we could get this crate running, then we would be close to getting an actual working implementation that works on top of WebAssembly for networking, to actually do asynchronous networking in WebAssembly through Rust, which would be really cool. Now, there's no actual way that we will get this fully working, and the reason is for the reason that I stated before, that like there are pieces of the specification of the WASI specification that just don't exist, that need to exist if you're going to do networking. Like you need to be able to create a socket, a TCP socket, if you want to do any kind of like TCP networking, right? Like hopefully that makes sense to everybody. And so the best that we're going to be able to do is basically to get this compiling, write out a list of all the things that we had to do to like hack it to get it to compile, and you know, where when it actually gets called it will panic or like just not do anything or something like that. And we can write that down and kind of make a list of like, these are the things that WASI needs to support in order for this to actually really get working. When we have that list, then we can maybe like actually go to the people who are making these decisions. And like, I think right now it's not an official W3, an official like body that's actually making this decision, but they're forming one now. In any case, like, you know, this will actually become a real web specification, an official web specification. And so, you know, it would be nice if we could go to the group of people and be like, hey, can you make this work? And I don't know, maybe that gets them to prioritize things. Who knows? In any case, we're going to learn a lot along the way, and that's all that I really care about. So, basically, my goal is to get this crate, this net2 crate, to go ahead and compile. And we're going to do everything to it, hack it up and chop it up in any which way, you know, in all the hacky ways to get it to compile. And then compile that list of things like, this is all the hacks that we had to do to get it to compile. And maybe we can start checking them off and get them to actually work later in the future. Any questions? I think now we're going to start coding 40 minutes in. Sorry, if people came here to see me type, that's not what my streams are for. I'm not very good at typing. So if there are any questions, I'm happy to answer them. And if not, then we'll kind of get into the meat of it. Get it to compile with WASI target would imply a non-functional implementation, right? Yes. So this getting it to compile really is like, do all the types exist? You know, are we, you know, really like literally the only goal is to like physically get it to compile. I guess the easiest way to do that is like, now getting it to compile means not only getting the net2 crate to compile. That would be fairly easy to do. We could just, you know, wrap everything in a don't like literally don't compile all these types if the environment we're targeting is WASI, and that would work. We could do that pretty quickly. But then when we go ahead and use this inside of Mio, it won't compile again, because like Mio expects this net2 crate to expose a certain interface, and if it doesn't expose that in the WASI target, then it won't compile. So what we really mean is get this net2 crate to compile in WASI, and you know, get it to compile in such a way that it still exposes the same interface, that it will allow Mio and this MioW crate to also still compile. When we actually run it, then it will crash, like it will panic or it won't do things properly and stuff like that. So yes, it will be non-functional, but the get it to compile in that sentence refers really to this tower GRPC. We want it to compile. Does that make sense? Cool. Okay. So I've already cloned down this net2, and we can take a look at net2 real quick. So net2 RS is Rust-Lang nursery crate. I'm pretty sure, like, if you were to write Mio from scratch and stuff like that, they would tell you, like, please don't use this. Like, I was talking to Alex, who's the maintainer of this crate, about this, and he was like, well, maybe a better solution is to get it to run on this different crate. I believe the crate was called Socket 2, but you know, that comes with its own challenges, and so maybe we should just go ahead and hack this up. So that's where we are here. Cool. Then this is it open in VS Code already. Let me go ahead and close everything here, except for this. Okay. So I don't know what that is. Oh, I think I accidentally created that. Let me delete that. Move to trash. Cool. So I've already started working on this a little bit here. So there's already a few changes. If you look at like the master branch that's on GitHub, you won't see some of these changes, but I'll try and take you through most of them. You can see here that there is, like, they're defining let me blow this up a little bit more. They're defining a module called sys here, and then like pointing the path for that module to a different place depending on the target, depending on some compiler flags. And so, for instance, if we're on Redux, which is a Rust operating system, then we'll go here. If it's on a Unixy operating system, we'll go here. And then this is what I've added. You know, if the target environment is WASI, then we'll go here. Windows is here, and so on and so forth. So we're kind of adding that, and I've added this WASI module here, and I've kind of stolen the implementation from Unix, from the Unix implementation, and we're going to go through and see how much sense any of this makes. And all of this is new territory for me, so I'm going to need your help, chat, to figure this out. We will definitely not be done today. I think I'm probably going to go until for another hour and 15 minutes. We'll see how I had my immunization today because I'm going to India next month, and it's kind of made me a little tired. So we'll see. We'll see how long I last. But yeah, cool. Then we can go ahead and try and we'll try and compile this. We can get rid of this bin. We're not trying to compile a bin here. So again, we're going to compile it with WASM32 unknown WASI, and we'll see all the errors that we get. And let's scroll up to the top here. Okay, so in this source extension file here, we have SetSocket is not being found. And if you look at what SetSocket actually is here, you'll find here that it's basically getting and setting options on a socket of some sort. And this is just a kind of a low libc level API that gets exposed out for setting options on a socket. Then it would be really helpful, maybe it's here, if we can look at WASI and look at the API. Okay, here it is. So this is the WASI API. It's all the kind of symbols that are being exposed to our WebAssembly program that allow it to do, stuff. So for instance, getting arguments and getting the sizes of arguments that are passed from standard in when you run a program at first, and reading from a file descriptor and stuff like that. So so this is it. Like, it's pretty small. There's not a ton of them here, and if you look at things that are on sockets, you'll find them here. So we can receive a socket, so receive a message from a socket. This is similar to receive in POSIX, for instance. Okay, that's interesting. We can send a message on a socket. This is similar to send in POSIX. And we can shut down a socket. And that's all we can do with sockets. Again, notice no way to create a socket. And there's nothing about options here and stuff like that. So like literally like this functionality and stuff like that doesn't exist. It's not even stubbed out in the libc implementation for WASI. And I think I have that down here. Let me find it real quick. I was looking at this earlier. So here is Rust-Slang's libc implementation. So this is basically the way that Rust talks to the C standard library, which is, the way the system calls that an operating system exposes. And just looking for this SetSocket opt here, and you can find it like, if we look here, for instance, like here's where it's defined for Fuchsia, for instance, the operating system, new operating system from Google. And here's where it's defined for Unix, for instance. But like if you search for WASI, like it's just not there. Like it doesn't exist. So nope and nope. So there is none there. Is WASI going to support threading? Yes, it will. There's a whole proposal for threading. I think they mention threading in the article that I mentioned before. Let me send the link here. So yeah, threading is something that's not even really specified in the WebAssembly specification. So WebAssembly as a concept, and it doesn't exist in WASI as well. So there's definitely some things to go through there, and there's some great articles on what threading looks like in WebAssembly running inside of the browser. But when you introduce the idea of it running outside of the browser, that becomes a little bit more complicated. And so it's going to be interesting to see what happens there. But yes, threading is 100% going to be needed to be supported. All right. So we just don't have this, like we have no concept of SetSocket op here. So if we go into here, and this is where, this is the thing that wasn't compiling here. What we could do is do something like this, where we say, don't compile this thing, or compile this thing if it is not target, and then we can do target env is WASI. And hopefully that gets rid of that error. And of course, like now this function, when it actually gets called, like if we're running in WASI, if it gets called, like it's not really doing anything now. Like all it's going to do is cast this payload here as some kind of pointer to void, and then return OK. Like doesn't do anything. So this is effectively an OOP. But we still need to expose it because we're going to like, this is a public function. We're going to expose it to the outside world. And so like we want it to be, we still want to like expose it, but for now it's going to do nothing. And when WASI gains the ability to, you know, set options on sockets, for instance, then we can come back here and like, hopefully libc has been updated to support this for WASI. And so we can just like remove this line and it will just all magically work then and stuff. So that's, but that will get rid of one error that happens here. I wonder if I can pipe this to, can I pipe this into head? That didn't work. Do I have to do? Oh, I have to pipe, this is all standard error, that's why. What is it again? I always forget the syntax. It's like 2 into 1. I don't know. Anyway, let's take a look at the top here. Yes, of course, the ampersand. I always forget that. Thank you, chat. We'll do that next time around. Cool. So like if you've noticed, we're not getting that error anymore. Like we're still getting this error where get socked op doesn't exist, but it's not on line 86 anymore. 80, yeah, it was 86 before. So like we fix that, and we can scroll down here to 104, and like we can just do the same thing, basically. Let's hack away. Say, only do this if we're not on WASI. Cool. So let's go ahead and compile this, and we can do now we're going to pipe standard error to standard out, and then put that into less. Nope, not working. Head. Why does the world hate me? Is it like that? Exposing to the world how I'm not actually a qualified programmer. So there we go. Thank you, chat. Appreciate it. Cool. I can never get it right the first time. Yeah, I can. It takes me Googling to get it right usually. Cool. So so now we have different errors that we need to get through. Let's see here on line 101. We're casting the length as a sock-len t. And I imagine sock-len t again is inside of libc here. Sock-len t. Nope. Did I copy it wrong? There we go. Yeah, so again, you can see how this is being exposed out. And if we look for WASI here, it will probably not be found anywhere. And in fact, let's take a look at source. Is it under Unix? Oh, it should be in master. Unix might be cloud ABI. No. This should be in, there we go, source master. WASI. Is this not in master? Yeah. Okay. And that's it's just here. So we just have one file with all the WASI stuff in it. Cool. That makes it easier, right? And here's the implementation of, so for instance, let's look, where was it again? Here. If we want to look for WASI sock shutdown, then we can Look here, and there you go. WASI sock shutdown. There it is. So this is like where all the magic is happening, where we're actually finally calling into the ether and hoping that those symbols exist. And you can see that, what was it called again? SockLint. SockLint just doesn't exist. So I don't know, maybe we can say here, I wonder if this will work. If we do target env WASI and then say type, can you do type declarations like this? We might have to do it outside of the scope. Let's do it up here. Type SockLint equals, I don't know, U32. Why not? And I think we're inside of an impl right now, which means we can't do this here. Let's put it here. This will be where we'll define all of our WASI stuff then. All right. So in theory, if we run this again, we won't see the same error. Yay, awesome. In theory, we could have libc shim for the WASI target north. That's true. Like, and in fact, like, I think the ultimate like way that this will get fixed is like, we'll have a list of all these things, like saying where, hey, we can't create options on, like, we can't get or set options on sockets. And then the thing to change is not, it's not this particular repo here. The thing to change really is libc here, this libc implementation. And the libc implementation can't really change until the specification actually exists that says you can get and set options on sockets in the WASI world. What is a libc shim? I think what they're saying here is a shim typically is like writing a piece of code that kind of stands in for another piece of code, and kind of stands in for it, and you write that stand-in as if it would work, but it's like really just like a thin layer that doesn't actually really do it. I think the better way is to kind of just keep our hacking local to this crate here, and not have to worry about creating a whole libc version. Is this recording going to be available later? Yes, I am recording right now. So it will be, I'll put it up on YouTube. You can follow me at Ryan_Levick on Twitter, and I will post it there. Cool. Cool. Okay. I think like, let me know if that shim explanation was good at all. I hope that makes sense. Yes, it probably makes, it's a good idea to explain what libc is. So thank you in chat for doing that. Basically what they're saying is libc is how you talk to the kernel level stuff. Like libc is really a C wrapper around system calls. So the system calls are the API that the operating system exposes to the outside world, and like libc is basically just like the C standard library. It wraps those system calls inside of C code, and that's usually how, like in Rust, what we typically do is not, we don't call those, like we don't invoke those system calls directly. We just use libc instead, because that abstracts away some ickiness for us. Exactly. So the example given in chat is, want to open a socket, you ask libc, which in turn invokes the kernel system call to do it for you. Cool. So we're good here. We cannot find value sole socket in this scope. So where is that? That is ext707. Oh, we're way down in here. Cool. Let's see, 707. Set receive buffer size. Okay. Don't know why that's not auto-completing. Where is set up here? I think set up is probably, oh, it's the libc call. Cool. And it takes some kind of like argument here called sole socket. We don't really need to know what this stuff does. If you're kind of new to this world, like I am, where you're not normally kind of at the level of libc, it's maybe a bit interesting to take a look. So I think the best thing for us to do is kind of just explore and see what these things do. We're going to go slower, but that's fine. Set, what was it called? Set opt. Where is this defined? Should be coming from libc, I would assume. There's a lot of these things. And there's no. Ah, never mind, not libc. Okay, cool. Yeah. And this is, yes, this is what we were looking at before, the SetSocket. Okay. So this was the thing that we were looking at before, and what we were seeing down below was like this being used. And so this opt here that we're passing to SetSocket opt is just a C end, which is just a C type here. And when we were looking at, what line was it again? 707. Oops. Ah, why does that not work? Here we're passing in this sole socket, which sole, that definitely is defined in here, and which is some number. We can Google what it is. What is sole socket used for? Let's ask Stack Overflow what this thing is used for. Sole socket is the socket layer itself. It is used for options that are protocol dependent. What? When retrieving a socket option or setting it, you specify the option name as well as the level. When level equals sole socket, the item will be searched for in the socket itself. Okay, so this is just a way of specifying the level of the socket. For example, suppose we want the socket option to reuse the address to 1. We pass in the level sole socket in the file we want to set. Okay, not super interesting. And unfortunately, again, WASI, we got rid of the page. We should keep that. WASI is not exposing this in its libc implementation. Again, because we don't have any way of setting options on sockets, so it makes sense why it doesn't have anything like this. Sole socket, yeah, and you can see it ain't there. So again, we can come up here and like, since we're like literally just trying to get this to compile, like we can just make stuff up and just be like, okay, this const sole socket is going to be a, what is it normally? C end. And it's gonna be then, it's just gonna be 0, because why not? There we go. Cool. And we have the same story here with so receive buff here. So let's just do the same thing. Our buff like this. Oh, so not soul. All right, and this is kind of, I guess it's gonna kind of get a little bit boring from here on out. So hopefully this gets a bit more interesting. Send buff, like literally we're just taking things that don't exist, but should exist at some point, and defining them to 0, because why not? And yeah, cool. Any questions so far about what's going on? We're now running into cannot find function v on line 731. Let's look down here. It's 731 v. Okay. And here's v. And you can see that they are basically interesting. Why is this different? Okay. We've introduced a this v thing that basically is just doing typecasting for us, so we can just, I mean, we could reuse one of these, but I'll just do it differently here. Target env equals WASI, and oops, and this should be fine. And we don't have this this constant here, and I think we're gonna probably have a lot of these, unfortunately. So instead, why don't we do this? We can make a module. We'll call it WASI C. WASI C. WASI libc extension, and then we can just use WASI libc extension like this, and now we can define that module only when WASI is there and use it only when WASI is there, and we can put all this stuff inside. So we don't have to every line say that this is only for WASI, like this. And hopefully we're in the same spot we were in before. Self. And it doesn't use lib. See, so now we're just gonna use everything inside of libc. Cool. Oh, why were we back to this? It is saying Sockland T not found, but we are using everything here. What? That's a bit confusing. Yeah, there we go. We gotta make it public in here. Ah! Pub. Cool. So now we're going to make all of this public. And we should now be back to where we were before. Cool. So now we can just go ahead and do the stuff. TCP, no delay. IP proto TCP. I hope everybody is enjoying watching me type this stuff. If anybody else has additional questions or thoughts or comments, always happy to hear them. All right, cool. We don't have this function ms2 timeout. Let's see, ms2 timeout. Interesting. Okay, so it's taking a timeout of some sort. I believe we probably don't have time val here. Question, are you planning to resume your work on the Game Boy emulator? Yeah. The question is when. This work here is kind of a bit more urgent for me because there's a very secret hidden work reason why I should be doing this. And this is also, I find this to be extremely fascinating. The Game Boy emulator stuff is fun. It's relaxing. I enjoy it, but it's a bit more known for me. And this is kind of pushing the limits of my knowledge here. So, which is why I'm kind of gravitating towards it. One thing that I will be doing is putting out like polls on Twitter, asking people what I should be working on, to get a better idea of what people are, into. So definitely make sure you vote there. I hope this isn't too disappointing of a kind of change in direction. But let me know if there's things that you would rather see than this. Let's type in time val. Yeah, so time val is coming through here. And time val is something that we won't get in libc wasm. So time val, oops, not time value. The time value of money. No, time val libc. Yeah, I'm glad you're learning a lot, but you are totally correct. The Game Boy rocks. That is true. That is definitely true. Cool. So this time val structure is basically just representing an elapsed time inside of libc. Not too hairy there. That's fine. We'll probably have to go ahead and create this though. So what was the exact error we were getting at? Okay, yeah, we don't have this. So we can go ahead and say that target env is WASI. So this will actually get us that function there, and now it's going to complain and say I have no idea what the heck saying, I don't know what WASI is. This needs to be equals. And it says, I don't know what. Oh, timeout to MS. That was MS to timeout, so now we need timeout to MS. And we basically, oops, need the same thing. Target env equals WASI. Okay, great, cool. That's awesome. So we did, maybe somehow timeout is implemented? I'm not sure. Who knows? Maybe it is. All right. Now we just need more of these bogus values here. There. Oops. Tomato? No. Man, some of these abbreviations and shortenings of words are just kind of hilarious. Like, just type the thing, man. I guess when this was created, it was a different time. Okay, IP proto IP. No, so. IPTTL is time to live for the IP address, I'm guessing. This is all like wonderful networking stuff. Oh, we're getting places, I promise you. We're just gonna replace all these things until something works. V6 only. All right. Who's having fun? Anybody? All right. Hey, okay, good. We're back to another function, set non-blocking. So this will make our IO non-blocking. That's good. What is this? Set non-blocking. What is this, an impl? Oh. Okay. I think there used to be a limit that linkers would only look at the first couple, maybe 8 characters for function names, which explains why so many standard functions are super squished. Oh, that's interesting. Like, yeah, I mean, I guess if you're writing a linker on a 8-bit machine, then you only have, I don't know, I guess for some reason you only want 8 bytes. I don't know. Weird. That is weird. Set non-blocking. So here's set non-blocking. It needs to be a result, but I think what we can do here is just take this and say, if we call set non-blocking, it will literally do nothing. Okay, like this, and CFG. Oh, we already got CFG here. Target env. So again, like there's nothing we can really do here because set non-blocking, like there is no non-blocking in IO in WASI. So yeah, what would we do here, right? We're just gonna do nothing. Cool. We're back to constants. Right in the constants. All right, door to linger. Do you door to linger? All right, I wonder what door to linger is. If anybody has any like it's a duration for lingering. What is lingering? Linger, libc. We're learning stuff here. Socket level options. Linger. So SO linger. This option specifies what should happen when the socket of a type that promises reliable delivery still has untransmitted messages when it is closed. The data type is a linger. This field is interpreted. Okay. So I guess it's like your socket has data inside of it still, but it's been closed. What should you do with it? And I'm guessing this says if you set the linger period for some kind of, 2 seconds or whatever, it will keep that data around for 2 seconds. That's what I'm interpreting that as. If anybody has more experience with system calls, let me know if I interpreted that correctly. We should be able to use this here and just do target env. Should have these written down somewhere, equals WASI. All right. Let's see how far that goes us. Now we're back to time val not actually being exposed here. And we want, maybe we should just time val. We can just, I think time t is exposed here. Get rid of that. Time. So we got time t. That's good. And what about this seconds t? No. That's unfortunate. How is it implemented in the Unix world here? And it's also seconds. Okay. Up until C99, 31 char macros, like 6 chars. Oh man. Yes, the world was a horrible place back in the day for people who wrote software. Cool. We're basically just going to steal this implementation here. I'm sorry. Going back to the code. We'll go back to our beautiful extension here and say we got a struct called time val like this. Time t we saw is given to us, and then we just need seconds here to be pub type seconds t, and I don't know, what is it defined here as? Like, is it a U32? Is it, let's see, seconds? Is it seconds? I read things that I shouldn't. Okay, I64, I32. What is it on Unix? Well, I guess it depends on. Oh man. What are they doing here? Yeah, I mean, interesting. I mean, WebAssembly so far is only 32-bit architecture. There are no native 64-bit numbers on WebAssembly, but of course we're exposing some things as that, which is fine. That works. It's just shoving two together. Yeah, I think there really kind of is no right answer here. I'm just gonna take C long, because why not? And that should do it, I imagine. And we got no linger. So now we got to figure out what linger is in here. Yay! That's easy. You can just literally just steal this thing. I don't want it like this. So our linger is just going to be a wrapper around two C-ints. And we keep going. SO broadcast, we're just like literally just copy pasting. Keep on going. All right. I wonder how long this is gonna go for. This is gonna be fun. Multicasting. I feel like this is if you want to learn about networking, like literally just take all these things and learn about what they do, and at the end you probably know a bunch. So doing some more here. All right, cool. So now we're back to we're back to a function here, IP2 in adder. Is that defined here? Yeah. And it's taking in an IPv4 address and returning this in adder thing that we have here. Interestingly, the Redux and the Unix implementation seem to be the same exact thing. Yet they're being defined twice. Not sure why. I'm just going to go ahead and do like this. Target env equals, I got to do any Unix, close it up. Target env equals WASI here. And I imagine it will complain it doesn't know in adder here. If we look at in, yeah, we don't have that. So it will yell at us for this eventually. But for now, we can go back up here and just keep on with the constants. All these hoppins. All right. Cannot find struct variant or union type IPMREC. That's fair. Let's see what this thing is. In the Unix world, it is that is certainly true and probably far less annoying. We have chat telling me a definitely superior way of doing things than what I'm doing. I will definitely take you up on that offer. FreeBSD like. Yeah, we can just do this, I think. And this in adder we're going to have to define as well. Let's just do it how they did it. Oh, what happened there? That was weird. We don't want this. And this n adder t is something we'll also have to define. Here they have it as U32. I think we'll do the same thing. So let's just grep for cannot find. And it would help if we pipe it. That definitely did not work because I took away the 2 into 1. Cool. Amazing. Okay. We're not so far away, people. We're getting there. So let's do cannot find value real quick. If I wanted to embarrass myself with my, well, could embarrass myself. Embarrass. Okay, if we pipe it into Ruby, we then want to, I'm not going to do it like this. I'm not going to do it because I forget how to take in Ruby standard. This is totally not worth it. Yeah, set is probably better. Sed. Well, really, we can just literally just do this, right? Anything until cannot, until anything till value, space this. What happens if we do that? Do I have to? Oh my God. Let me just do this. That didn't work. Oh my God. I'm embarrassing myself. Okay, that's good. How do I? It is not loving this backtick for some reason. Set escape. This is just not worth it. Oh man. We'll just say any character after the space. No. Oh well. And well, that was a failure. I'm sorry, people. I'm really sorry you had to see that. I'm really sorry. We're just going to do it the old-fashioned way. And in fact, I think what I'm going to do is just take this. Oh, come on. VS Code failure. We got to add... Yeah, it's too late now. It's too late now, chat. I'm sorry. It's just not worth it. We're just going to go through and copy them one by one. Yeah, that's the same thing. Oh, I already reused this too. Can sock stream AFNet 6. If I think we might be in a better place now. I would also spend the time on a hack as well, but not in front of people because I'm embarrassed. Cool, we're doing some stuff. Oops. Actually, I added it twice, didn't I? Yep. Right for that. Okay, there's another thing we got to implement here. And for those still following along at home, probably got about 20 more minutes in me before I pass out here. So just so everybody knows. Oh, interesting. Got some differences here for Android. I think we're just gonna copy them on over. Say, we'll do the not Android thing. I don't believe we've defined this, have we? No. All right. This is fine. So we got an looks like I'm guessing a IPv6 address here. Cool. All right. Where are we at now? Hey, we're out of this file. Looks like this file might be good to go. We just had to add all this crap here, which is fine. Rather waste 10 minutes to write the script than 1 minute to do it manually. That's, you know, I'm the same way, but I feel the pressure, you know, I really do. Right here, deep inside. Cool, source socket, where are we at? This is gonna be fun, because again, like we don't have sockets. Well, we do have sockets in WASI, but we don't have them supported very well. So it's gonna be interesting to see. This is weird. if it's Redux, this and this. I mean, we have cend and cend. Yeah, that's fine. I guess we'll do it their way and just do a whole new definition. I'll do it down here. Target env is WASI. Hashtag no pressure, yeah. Okay, there is no function bind in module C. That makes sense. What is module C? In C here. Okay. Where is bind? Oh, and this is in the impl. No, it's not. Is there module C? Okay. There is no bind. So this is for the Unix one. Pub use. Are we doing pub use here? We are. Okay. So it just means that there is a bind in libc that we don't have in WASI. And bind is, yeah, just binding a socket then. Let's look at the not BSD Unix version of bind, because that's probably what we want. I feel like there's probably a better way. Like we probably want to bring this extension module out somewhere so that it can be, I mean, out from here, so that we have it maybe in its own file or something like that, so that we can just easily refer to it. Chat is asking, just coming, what are we building with WASM this time? Where do we start? We are trying to get, at the end of the day, this, where is it? This project here, Tower GRPC, which is a gRPC Rust implementation running in WebAssembly through WASI. And we have gone all the way down the rabbit hole to where we're in this low-level networking library called net2, and we are basically stubbing out libc for WASI. I hope that in some way explains it. We're at the end. I got about a little, maybe 15 minutes left, and then that's it. So I hope that explains it. It's mainly been me copy pasting. So I hope that's okay with everybody. So we're at the point now here where we're basically just going through and building it and seeing what's not working. And we found here that we don't have a bind function here in this module that we have inside of WASI here, because libc for WASI doesn't have a bind function, because there literally is no way to bind a socket in WASI. If we look for bind here, we ain't gonna find it. So there's that. Yes, there was some explaining going on. That's true, chat. Also, some poorly done sed work. A younger version of myself could have done that, but it's been a while. I'm losing it. Anyway, yeah, bind again is this. This is just an extern, right? Yeah. Trying to think what's, you know what, we'll just put it in here for now. I think we can do it like this. We'll clean up the structure a little later on. Let's see if that takes care of it. Cool. So we got bind now. Yeah. This is why I was saying we want to have these WASI libc extension module somewhere nice to be able to refer to. I wonder for now, can we do pub use? Is crate? This is, by the way, this this whole crate is Rust 2015, so it's not Rust 2018. Which means sometimes we have to do things a little bit weird. And I'm not sure if crate actually exists in Rust 2015. I cannot remember. But anyway, this was in Ext, and it was... Oh, and it's... Yeah, it's... We got to do this. Crate CFG. Target env WASI. And what do we call it again? My memory is just so bad. It's embarrassing. Yeah, we just want to take that. So if it's WASI, then we're gonna also pub use this. Oops. Will that work? Hey, I think it worked. Although unresolved import, what? I don't know why source Unix is now freaking out. sysc self cent. There should be again in WASI C. We're pub using libc here, and libc has a cent in it. So I'm not exactly sure why this is freaking out. And it's even saying can't find socklen T in module C, but that's also not true. Is it this? Why would that be? And we don't need this because if we're in this file, we for sure are in, like if this file is compiling, we're for sure in WASI, so we don't even need that. Definitely confused why that would be the case. I wonder if this is... And if I just use this, oops, strange. Yeah, that worked. Not exactly sure why this one. Oh, I don't need this, maybe. Huh? No idea. Not sure why that's not working right now. Okay, cool. Yeah, we don't have listen as well because, yeah, listen is literally not a thing you can do in WASI. So, listen. I think we'll take this. And connect. All right, we're getting to the end here. We only have 5 minutes left. I'm gonna stop here, just because I think everybody gets the idea of what needs to be done, and I can kind of finish this up without you having to watch me do it, which is probably incredibly boring. Let's go back real quick and just talk about what we did, and then can make plans for the future. So we talked about what WebAssembly actually is, that it's a conceptual machine. We can go ahead and somebody has come up with the right way to get out the actual names. Thank you for the work. Awesome. That's amazing. So we've looked at WebAssembly. It's a conceptual machine. We found out that we can take the code from this conceptual machine and compile it over into code to actual assembly that runs on our actual machine using tools like Lucette or WasmTime or LazarMer. And then in order for that code to be useful, we want it to be able to actually talk to the host machine that we're running on. And the way that we do that is by then using those same tools and providing a WASI compliant runtime. And that WASI interface allows us to talk to the host machine in a very specific way. We talked about why this is interesting. It's interesting because WebAssembly is completely sandboxed and it's a lightweight runtime. So we can run applications in a cross-platform way, much the way that Docker kind of abstracts away an operating system. As long as we have a kernel that, it understands, like we can basically specify the user land that we're running in. WebAssembly takes that a step further or a step higher level and says, I will provide the machine. You don't worry about that. Just give me the program and it will run it. And this has a bunch of interesting use cases. And then we kind of said, okay, for today, what we're going to do is try and get networking running, like some deeply networked program like this Tower gRPC and the example client that they have here, the Hello World client. We want to get that running. And we tried to compile it, and we realized that it was basically the fault of this net2rs crate, why things were not compiling. And the reason is because it assumes a fully featured libc, which WASI does not have. And so we were going through and stubbing all of that and just basically saying, well, here they're defined, they're not correct, and it will definitely not do the right thing if you run it, but we're going to get it to compile. And if we keep doing this, eventually all the compile errors will go away, and we will end up with awesome things where we can run a gRPC client in WebAssembly. It will probably crash horribly or not do things, or who knows what will happen, but it will run nonetheless. And that's it for this week. I want to thank everyone in chat for helping out. You've been awesome. If you have any more questions, let me know. If you have any any thoughts on what I should do next or something like that, what you would like to see in a stream. We got somebody wanting to see Game Boy. I'm definitely cool with that. We'll definitely do more of that in the future. I'm going to tweet out all this stuff later on, including a recording of this. And I'll tweet out like my fork of Net2RS, so that if you want to take a look at the PR, if you want to contribute or talk about it or figure things out together, that's great. Make sure to follow me if you're not already. I only announced this stream on Twitter, so you probably have seen my Twitter before. But if not, it's at Ryan_Levick. So check me out there. And that's all she wrote, I think. All right. Few last questions here. Docker really gets complicated in practice because it tries to expose a lot of host level things to containers, networking, storage, whereas with WASI, it isn't clear yet the way the API will evolve and what will be in scope. Potentially runtimes will have private APIs for cool features. Oh, private APIs is not something I've thought of before. That's going to be interesting. The promise of WASI and WebAssembly is that if you write a program that you can compile it to WebAssembly and it should just run. Private APIs kind of works against that. Like the whole reason to have a spec is so that there's not just one implementation. So we'll see. We'll see what kind of comes out of it. It's super early days for this. We don't even have a way to create a socket yet. So let's hold our horses. But I know a lot of people are definitely interested in this. There's already companies that are kind of jumping on board here. I mean, one of the implementations of a WebAssembly runtime is from a serverless company. So, yeah. Are you at the Rust Hack and Learn meetup next week in Berlin? I am. I co-organize it. So if you live in Berlin, come on by. We're going to have Lynn Clark there, who is an awesome resource and person who's basically been instrumental in getting a lot of this running. In fact, she was the one that wrote this article here about introducing WASI. So if you are in Berlin and want to hear her talk, and she knows more about this than I do, then come on by. We'll be there. We can talk about this and geek out over it. And that's it. So I hope everybody has a good evening, morning, afternoon, and night, wherever you are. And hope to see you around and see you at the Berlin Rust meetup next week if you happen to be there. So thank you very much.